some of what I've got to say has got quite a lot of relevance to what we've just been talking about. As we found with the printed line follower courses, especially the half-size one, making test courses available to people very cheaply, very easy to get in and out, makes a significant difference to how people get into these competitions. And with line following, we've got that cracked now. This test course does the job and it doesn't cost a lot. So having sorted that out, I started thinking about whether we could do something similar for a maze course. And I wondered if a single rule change could reduce the cost and time to make a half-size maze very considerably. I've spent far too much of my life in the last few years making Micromouse courses. So I first of all thought about whether it be possible to use printed courses for solving events, and decided there were two problems. It's difficult to change the maze, and it's impossible for the judges to decide whether a mouse crossed a wall. So this is my modest proposal. Reduce the height of the walls. Okay? So saying the walls are expensive and difficult to make. The set of walls for the half-size competition course used 5 reels of 3D printer filament and took weeks to make and fettle. With 3D printing, the cost and time is proportional to the volume. Reduce the height from 25 millimeters to 3 millimeters and reduce the volume and cost by 88%. 3 millimeter walls can be lasered from 3 millimeter white acrylic with good accuracy. You get lots from a single A4 sheet, costing about £4. That's how these were made. So that saves a lot of the costs of the thing, but there's still a problem to get over, which is putting everything in place. Hang on, what's gone wrong now? That? No. So that worked, okay.
Yep.
So drilling holes in a baseboard accurately is difficult. But when the posts are only 3 millimeter high, there's no great advantage to being able to take them off. A bit of two-part epoxy under the post is much easier than drilling a hole and poking a post into it. So I borrowed Ken's idea of a drilling jig from a Minos quite a few years ago and made a couple of gluing jigs. So these are lasered out to the A4 sheet, and you get 2 of them out of one sheet, and you can see the spaces where I lasered out posts, and they're of course accurate positions to put posts into. You glue a set of 8 posts to start with, and then fit the jig over them while you glue the next 4 down. So with the 2 jigs, you can glue 8 posts at a time. If you use 5-minute epoxy, you can glue about 48 posts an hour. Once you've cut your base to size and painted it with blackboard paint, you can make a 10 by 10 maze in less than 3 hours. I made a 9 by 6 maze to fit on the back of the A1 board that's got the half-size line follower test course on the back. There can be an issue with build-up of tolerances. If I did it again, I'd use a long straight edge to make sure the jigs were really well lined up. I found a couple of places where the posts ended up a little close together. But the thing about the laser cut walls is they're sort of chamfered on the edges. And if there's a tight space, you turn the wall upside down, and that gives you about another millimetre. And I also made some walls a millimetre longer for if I came up with a big gap. The outside walls around the edge of the maze can also be glued down because they're always going to be there. Because there are no post holes, you don't need a thick base to keep the post vertical. So I went down from 12 millimeters to 6 millimeters, 6 millimeter plywood. This saves some money and keeps the weight down and makes the maze easier to handle. Any questions so far? Deathly silence, okay.
Which slide should we be looking at, Duncan, just to be sure?
We should be looking at one with 2 white bits that look as though they'll fit together with a
sure.
roller on it. Okay. Let's see if I can click onto the next slide now, see if I can find a way of doing that. So you get lots of posts and walls from an A4 sheet. You get 2 jigs plus 30 odd walls and posts from a single sheet of plastic. So that's enough for a 5x5 test maze. Each extra sheet adds about 70 walls and posts. You need 7 sheets, that's 28 quid's worth of acrylic, to make a 20x20 full competition maze. Now the filament for the competition maze that we've got, we spent over £150 on that. Right, let's see if I can get back to the next one. So for a test course, the easiest solution to timing sensors is to get the mouse to do the timing. So for a test course, you don't need any timing sensors. I would guess everybody who's successfully able to program a mouse knows when it's reached the center and consequently knows how long it's taken. For competition courses, I did a bit of investigation using a periscope to get you, and a bit of acrylic cut at 45 degrees top and bottom, polished, makes quite a good periscope, so that works. The only problem with it is you can't, because you've got to cut a hole in the maze at that point, you're stuck with that sensor position, so you might need several sensor positions and move the timing gear around underneath it. Okay, next. So, for me, the easiest sensors to use would be line follower sensors raised up a bit. We know they work, and they're still quite low down because the walls are only 3mm high, and they give very good resolution and repeatability, and we've heard this afternoon how you program them. However, if you want to modify an existing mouse, you want to know if a reflected light sensor works. So I made up a sensor to see what happens. The sensor was clamped to my bench and the wall moved backwards and forwards in front of it. Can you see enough of that, or is it too small? Good, right.
Yeah. It's okay.
Yeah. So you can see what I was doing there. Let's move on. So this is the sensor circuit, just so you know what I was working with. It's pretty standard stuff. I've used 2 transistors instead of an FET because I didn't have a through-hole logic level NFET to hand. I make one measurement with the LED on, and then another one with it. One measurement with the LED off, and then another one with the LED on straight away, so I can cancel the ambient light to a large extent. And it's the difference in those 2 values is what I'm using. The other thing that's slightly unusual, I've used a narrow angle visible LED so I could see what was going on. This was probably a poor choice. I think I'd have got better results with a slightly wider angle in infrared. But let's see what the results are. So this is what we've got. So the reddish one is a 25mm wall, and the blue one is a 3mm wall, exactly the same sensor setup. When there's no wall present, so this is just looking at whatever you've got back scattered off the black top of my bench, the reading is 7. Okay. Now you can see that when you get very close to either sensor, it goes non-monotonic, and the one with the low wall goes non-monotonic when it's further away from the sensor. But it's still only 9mm away from the sensor. And you've got a good slope out to about 35mm. So you've got a sort of 26mm, in quotes, linear range that you could use. When you get close to the wall, you lose some of the light over the top. I think it would do better with 2 LEDs. So you've got one sort of shining close in and one shining further away. I think it would also improve it if I got the LED closer to the floor. There's a 3mm gap under the body of the LED here. So the center axis of the LED is 5.5mm above the ground, i.e. above the wall. So if you took that clearance down to 1 or 2mm, you'd almost certainly move that hump a bit closer to the mouse. So remember that the distance between walls is only 84mm. So a 40mm wide mouse will have only 22mm clearance when it's in the center of the cell. So that falls nicely in the middle of that linear range. You can detect walls out to over 50mm. So with a 40mm wide mouse rammed hard up against one wall, you can detect whether the other wall is present. I think it can work, but I would use line sensors for this kind of maze. Any questions about using a reflected light sensor? Deathly hush. Okay.
Quick question. Did you think about actually looking down on the walls rather than from the side?
Oh yes, this is what you would do. So you'd use a conventional line sensor, looking down on the walls. You've only got to raise it up by 3mm of what you're doing anyway with a line sensor. So it's straightforward stuff. Now this is the other advantage, because, and this has very great significance for UKMARS bot. Because the walls are so low, there's a lot of space over the top of them. And I don't know if this is clear, but if you take a standard motor gearbox, exactly as used on UKMARS bot, you can make a top hat-shaped wheel and put it over the motor so that the point of contact is well inside the width of the motor. So you can have two motors end to end with odometry behind them and still work on a wheel track of about 40mm with the rest of the mouse sticking over the walls. Now I had a quick look at the UKMARS bot PCB, and it wasn't entirely clear to me that the space where the motors are attached couldn't be freed up to move the wheels in on a next revision of the PCB. I think that between the front and the back of the mouse, all there was connectivity. So I may be wrong.
The encoder wheels are what stop the motors going more inboard than they are.
Now, I would want to leave the motors exactly where they are and just move the point of contact of the wheels inboard.
Oh, I see. Yeah.
Right?
Okay.
Mm-hmm.
Okay, so you can overhang the walls and it doesn't have a disastrous effect on the centre of gravity of the mouse. And as I say, I think you could make UKMARS bot work on these low height walls with just the sort of changes that I should imagine you're going to be making to the PCB anyway. Okay, let's have a look at the next slide. So we got some conclusions. It's a modest proposal only in the Swiftian sense, right? And it's obviously not very modest. It's a significant change to the maze. But to sum up, it is cheap and easy to make. You can make a test maze for a few tens of pounds, maybe £40. So you're spending about the same amount of money on the maze as you are on a UKMARS bot. Right, you can kit yourself out with a line follower test course, a maze test course, and a UKMARS bot for probably about £100. You're going to spend no time sorting out the line follower course. You're going to spend maybe a day sorting out the test maze, and then you can get stuck into your robot. The existing competition maze took many weeks to make. So, and the only reason I could do it at all was because my son had access to a big CNC router for drilling all the holes accurately. This would allow anybody who wants to make a competition maze at home. The mice can be cheaper and easier because they've got all this space. You're not trying to cram all this mechanical stuff into a tiny footprint like you've just been talking about. And of course, the same mouse can almost certainly do line following, wall following, and maze solving with different sensors plugged in. But existing mice will need to be modified. It should be possible, but probably not very easy, to make mice that will run in either height of wall using reflected light technology. But you'd have to think carefully about that. But for me, the big attraction is for new mouse builders. You know, it's cheap, it's easy, it's almost off the shelf. And now we've got questions.
Okay, does anyone have questions for Duncan on this one?
So Duncan, if there's no wall, I should see little posts, right? Is that are glued to the base?
That's right, yeah. So there will be a post in the middle of the target square, but I don't think that's going to upset anybody.
Right. I just don't see the posts, but I think that's because you put a wall on every one.
Oh, hang on. I'll see if I can show you. I mean, technically, you have to have a wall on every one.
I understand.
Yeah. Where is it? There?
Oh, okay, good. All right, great. I understand. Thank you.
Yeah. So it's no more hassle setting out a maze than with the other stuff. You know, you just plonk the walls in where you want them to go.
Okay. Anybody else? Questions?
Yeah. So Duncan, this method, I noticed that there are several other people running maze solving style competitions, and there's two categories that look like they're printed mazes, right? One is that looks like yours, apart from it's not raised, it's pure printed. The other one is effectively a line follower competition that uses a maze as opposed to a fast track. Is the advantage of this system the fact that you can see the walls from some distance away? Whereas if you had a purely printed maze, it'd be tricky maybe for you to pick up those walls.
For me, the biggest problem with a purely printed maze is for the judges. How do you tell whether the wheels have run over a wall?
But yeah, I mean, my question is about finding. I mean, you wouldn't want mice don't make a decision for the fast running mice. They make a decision before they've even got in the cell because they can see the wall ahead. So with the slightly raised walls, you could potentially do that. I mean, I guess even with a printed wall, maybe you could do it. It might be a bit more tricky with cheap, simple sensors.
Well,
I'm just trying to,
with downwards looking sensors, if you put those at an angle, you can look quite a long way ahead. With the previous generations, I think it was WAM or the one before that, we mounted a sensor quite high up, looking forwards at maybe 45 degrees or something like that. So it was actually looking at the white-black transition on the floor to detect the wall sort of a cell ahead. So that's unchanged, but you do have a slightly better chance of looking sideways at a wall and detecting it.
Okay, I'm going to have to call time a little bit here, just in the interest of us. I think there's a football match on tonight. I'm not sure.
There's a rugby match on, even as we speak.
But Duncan, thank you for that. My feeling is that we've kind of almost got another challenge here. We've got sort of conventional mazes, there's printed mazes, and this is an interesting kind of blend of the two, but it is actually a different challenge to people. So I guess the proof of the pudding is whether people would want to build robots to run in here. and that might be the question that we need to just put out to people. But nevertheless, I kind of would encourage you to publish the stuff that you've got, because if people want to start doing that, let's see them start doing it. It's always interesting to see people taking on these new challenges.
I think there is no point running two different heights in the half-size maze. You have to make up your mind.
Well,
it's going to be for UKMARS part.
Yeah, you do need to be careful of creating so many events that you get one entry for every single one.
Yeah, I agree.
It would just occupy extra time on competition days and so on. I was hoping to get this in before too many people had invested too much time and effort into half-size mice, but I only thought of it 3 months ago or something. So
Yeah, I guess for me the issue is trying to keep some kind of similarity with international competitions. That's probably the biggest thing for me in considering this is that we, other people running half-size mice are running them in walls, and that's quite a big driver for me. I'd like to see us be as consistent as possible. So if people want to start competing abroad, then that's something they can move on to do.
you see, one of the things is my audience for this is exactly the wrong kind of people. I'm aiming at people who want to look at a competition and say, I want to do that. And with the other solving competitions, the issue of building mazes is very significant.
Yeah,
I bet there might be another alternative, and I'd like to see this in person. It's sad that we obviously Minos was made virtual, and certainly whatever happens, Duncan, I think if you can bring this along to Hazelmere competition, I'd like to see it in person. But the other thing is we could run another maze solving competition on a line follower maze track with standard line follower robots. Right?
Yeah, but you can't judge it. That's the problem. As soon as you've got a mouse traveling at 3 meters per second, you can't tell if it's gone over a wall or not.
If it's traveling at 3 meters a second, it's definitely gone over a wall.
Yeah. Okay.
Guys, okay, I think we're going to have to kind of cut the discussion on this, but thanks for bringing that. We have got one more piece, which is Derek, who's patient.